Hello, everybody. This is Moti from Klevoya, and we're going to give a webinar on things to do before you deploy your smart contract onto a public net, and or otherwise how basically not to get hacked. Steps that you need to take not to get hacked whilst you're doing your EOSIO smart contract development. So with us we have Christophe Michel, and he's going to be taking us through the presentation. Christophe has many years of development experience, and he's also written a lot of smart contracts, audited a lot of smart contracts, and literally wrote the book on EOSIO smart contract programming. So I'll hand over to Christophe, who will take us through the bulk of the presentation today. Christophe.
Yeah, exactly. Also welcome to this webinar for everyone from me. This will be about EOSIO smart contracts, and more specifically about what to do when deploying your contracts to production. We noticed a lot of developers are afraid of doing this step because you hear about all of these multi-million-dollar hacks that are happening in the blockchain space, and just because there was a small bug in the code. And we thought it's a good idea to have a checklist that you can really go through and then see if you did all these steps, and if you feel more confident after doing that, if you're then actually deploying your contracts to the mainnet. As Modi said, I'm Christophe Michel. I work for Klevoya as a lead developer, and Klevoya is what we do here is more of we provide developer tools, and one developer tool that we recently announced was Hydra. It's a unit testing framework. And so this webinar will be twofold. First, we're going to show you how to use this new unit testing framework that we developed for testing EOSIO smart contracts, because it ties really well into the whole idea of deploying secure code to production and feeling confident in your code if you actually tested them in the first place. And then there will be a short practical part in the beginning, and then afterwards we will go through this checklist. So let me share my screen and get started. So first we'll look at Hydra. It's a unit testing framework for EOSIO smart contracts, and there's some nice features. You don't need to run your own local node, which helps you in the end to get started testing really fast and quickly. You can read more about it at klevoya.com/Hydra, and I'll give you a practical introduction now. Well, you should see my code now. Okay, so here I have a very simple smart contract that we can test. It's just a message board contract, and there's just 2 actions. I hope the screen size or the font size is big enough for everyone to read.
Yeah, it's good.
So, okay, we have first the sign up action. It takes an account name, a chain account name and a string name. And then it requires the authorization of this chain account, and then creates a user with this account and this name. So checks if the user doesn't exist yet, and then it creates a new entry in the users table with the account name and the display name. And if the user already exists, it just changes the account's display name. And the second action is the send message action, where you can actually send a message. So you send it to somebody with the message. And again, we require the authorization of the sender of this message. And then we check if both of these accounts exist, the from account and the to account, do some restriction on the message size. And then we send a notification to the recipient, and then print out this message here. And how you would usually test it is by downloading EOSIO and then installing it and running a local blockchain, importing keys, setting up a wallet, and creating accounts, and then deploy this contract and then run some tests, run some test actions against it. With Klevoya, you can do install it like this, like it requires npm and node. So you can install it globally, npm install global at Klevoya/Hydra. So I already did this part, so I don't need to do it again, but that's how it would work. And then you have the Hydra CLI available. And if you say Hydra init, it asks you what contracts would you like to test. And here's only one, it automatically detects it. So let's select this message board contract. And it also asks you what tables would you like to fill with initial data. That's another nice feature of Hydra that we're not going to use today, but just quickly, Hydra also allows you to load contract table data from actual JSON files. So we would define it in a JSON file and then load this contract data. And then it creates hydra.yaml file here on the left side, which has the configuration. So it's basically just the mapping of what you just selected, a message board with the ABI file and the WebAssembly file and some options that you don't need at the moment. And then what you also see here is created this boilerplate message board, a test.js file in the test folder. And so whenever you run Hydra init and select a contract, it creates a new boilerplate test for you to quickly get running. And to quickly step through it, first it imports the Hydra environment, the load config in the blockchain. Then it loads the config file from this hydra.yaml file that we just saw. And then here's already the testing boilerplate. So it creates a blockchain with this configuration, creates a tester account. And then before running any tests, it does something once. And what it does is it sets the contract of this tester account to this contract message board that we define in this config file. And what it also does is it updates the authorization of this account to include the EOSIO code permission. We don't need it for our contract at the moment. Usually you need it when sending inline actions, but our contract doesn't do that. But we included it in the boilerplate because oftentimes you do need it, and then it's good to already have the boilerplate for it. And for each test, it resets the tables. We don't need this at the moment either. And here we can write our first test. Let's say it can send the message. And the way you write the test now is on this test account where the contract was deployed, you can say contract and then the action name. So the action name here would be, let's first create some users by signing them up. So we create 2 users, sign them up, and then send a message from one user to the other. So first we need to create 2 users, and the way to do it is quite simple with Hydra. We say user one, so it creates a new blockchain account, and this will be the account name. User two. Then here we can say, check the arguments again, it's called account and name. So it will be account user1.account name, and name, let's just call him user1. Then we also need to provide the permissions that we send it to, because here it's checking for the authorization of the account that's signing up. And this is the same like with any EOSIO permission. So it has the same API. It takes the actor, which is again the first user, and then the permission name will be active here. In Unix, I always get autocomplete when I do any of this stuff. So we sign up the first user. Let's do the same for the second user. User2 account name. And now the way we test this action is we check if the table, we check the table data and we check if the user was inserted into this table. And for that, you can use this get table row scoped action. First, it takes the table name, which is the user in our case, and then the scope, which is the message board. Then it should be equal to user1 and this name that we said the username should be here. And the second user should also be created, like user2, user2. And then the way you run it is by simply writing npm test. And notice for the user accounts, we didn't need to set up any private keys, public keys, or wallets or anything. We just say create user and it's all handled in the back for you. And yeah, the test passed, like to see if it's actually working. Let's make an error here. Let's say we expected the name to be user23. Yeah, now it failed and it says expected user23, but it was user2. So this worked well. But let's see, what if you wanted to test an action that doesn't have any effect on a table row, like this send message action that just prints a message? You can also quickly write a test for this one. Then we say contract, instead of the sign up action, we do the send message action. And it's from, to, and message. So from, let's send it from user1 to user2. And let the message be hello. And the authorization should be the first user. And now each action or each transaction that we send here returns a transaction trace that we can check. So, and each transaction trace has an action trace with all the actions, because one transaction can consist of multiple actions. In this case, we just want to check the first action trace of this send message action. We say the first one, and .console is how you get the printed statement, and then we expect it to be hello. Just need to change the number of expected insertions to 2 here. And then if we run it again, it fails with expected hello, but received message sent to user2 hello. It's because we did this prefix here, message sent to. So let's fix that. And then run the test again, and now it should pass. Yeah. And yeah, that's basically all I want to show you for Hydra. As you see, it's very quick to get started writing your tests. And if you want to find more about Hydra, you can check out our website here. Either klevoya.com/Hydra, or you can go to the docs page, docs.klevoya.com, and here's all these things I already just mentioned and showed you, like the quick start guide, some overviews, how to load table data, how to deal with printing and deferred transactions, and also how to integrate it in continuous integration, which works really nice here because you don't need to run a local node. So what I always do is I set up my tests and then let them run whenever I push to a repository, and then the tests run automatically. So that's Hydra, a way to quickly start testing EOSIO smart contracts. And now for the second part of the talk. Could actually just have shared the same thing here. The slides are here. Let's talk about the EOSIO pre-production checklist. So some things you should do before deploying your contract to production. So the first one, which might seem obvious, and it doesn't only apply to blockchain development, but just software engineering in general, but it's still always as important as in any other discipline. It's to follow the best coding practices, like keep your code and the contracts modular. For example, don't mix your token contract with your business logic. It makes it harder for you to understand. And also, if you ever want to get listed on an exchange, they usually want to see a plain token contract and not mixed with any of this other stuff that could lead to advanced complexity and vulnerabilities. Use meaningful names and naming conventions. Like usually C++ uses snake case, which is all lowercase, and using underscores as a separator. But you can just pick any and then stick with it, whatever's your preference. And choose clarity over performance, which means don't prematurely optimize your code. Just make it clear what the code does. And if you run into a performance bottleneck at some point, you can go to it later and fix it up. And of course, document your design decisions and use version control systems. And another important step is to always keep your code up to date with the latest EOSIO releases. When I say EOSIO releases, I'm thinking about two different things. Like first, there's the EOSIO release, which is how the node EOS runs, how the node runs, and how the blockchain works. And then there's the EOSIO CDT, the contract development toolkit, which has all the tooling when you're writing your smart contracts. And it's important to check both of them for any updates. For example, EOSIO wants to deprecate deferred transactions, so you shouldn't use them anymore. But also in a new contract development toolkit version, you might see some deprecations or some additional things. Like recently they added new kind of public keys, so they're not only elliptic curve public keys anymore, but also web authorization public keys. And so keep checking this, and also make sure if there's any new helper classes defined in these EOSIO contract development toolkits. For example, some really useful ones that I keep using over and over are the EOSIO asset class. It's great when you do any token arithmetic, because what it does, it includes automatically an overflow check. So instead of doing your calculations on pure integers, which might overflow and lead to bugs, put it in the EOSIO asset class and do all your calculations with this one. Then if you're dealing with time, the time point class and the microseconds class are really useful. For example, microseconds allows you to define time spans. You could just say days of 1, and then it will give you the number of microseconds in a day. And then you don't have to hard code 24 times 60 times 60 times 1 million, things like this, which is prone to error. And also the action wrapper classes are really useful because they allow you to get compile time checks on the action arguments. So you define the action wrapper and then define the type of the action, and then you'll get compile time checks for your code. And another good thing to do is to check for known vulnerabilities. Like here we at Klevoya, we created an EOSIO weakness classification registry. It's public and community curated. And what you can do is you just visit it. And here you'll see a list of all kinds of vulnerabilities. For example, fake notification receipt. And what you see is a summary, like a description of the vulnerability itself, like sample vulnerable codes. And if you scroll down, you also see a test case. If you scroll down, you see code that fixed this vulnerability. So check this out, read through them, and yeah, see if you noticed anything that might apply to your contract. Yeah, another thing is to always make sure to compile the production builds. Like sometimes when developing smart contracts, we need to differentiate between a test build and a production build. For example, when you're testing, you might write an action like a test reset action that clears all the table data so you can run your tests again. Or alternatively, maybe you're deploying it to a different chain and this chain has a different system token, then you might also define differences here. But yeah, make sure you're compiling actually the production build. And a good way to usually check this is by checking the generated ABI file. Like browse through it and see if it contains anything that shouldn't be in here. For example, this test reset action, if you see it in your production build. Yeah, go back and see if you're actually compiling the correct one. Another really useful thing is to implement a safety switch. Like, let's suppose something goes wrong or something seems odd to you in the way someone is interacting with your smart contract. And then it's helpful to have a safety switch to turn off the contract temporarily. And it just buys you time to analyze the contract and check for security vulnerabilities or anything else that seems off. And an easy way to implement this is just by having a global table and the pause action. And this pause action takes a Boolean like true or false, should the contract be frozen or unfrozen. And what you do is you just store this pause state in a global table. And then in any action, you can perform this check running action, which then grabs this table entry and checks if it's not paused. And alternatively, if you find yourself already in a production environment and you see something strange is going on, you can also always upload an empty contract, which then it still allows people to send actions. They won't fail, but they won't do anything. So in case you didn't implement a safety switch and you need to buy some time, that's also a good idea to keep in the back of your mind. Yeah, and of course, it's important to test your contract. We just saw Hydra, so I will just skip over this, but there are other testing environments, and in the end, we can also show you some comparison between them. And it's also important to do a public beta test on a testnet. Like this way, it allows you to get real user feedback and it catch some bugs that you wouldn't immediately catch when writing unit tests or when running your code in isolation without any other smart contract interactions. And there are many different kind of testnets. The most prominent ones are Kylin and Jungle testnet, but there are also chain-specific ones. For example, if you're deploying for the WAX mainnet or the Talos mainnet, they also have their respective testnets. So there's the WAX testnet and the Talos testnet. And the difference between all of these testnets is usually that the testnets try to mimic the chain parameters of their mainnet chains. So WAX would run with the same parameters and code as the WAX mainnet, and same for Talos. And Kylin and Jungle usually have the same parameters as the EOS mainnet. And here on the right, you see a whole bunch of testnets that you could use. If you want to see them, you can go to blocks.io and it will show you this list here that I put on the right side. And then you can see if there's a testnet for the chain you want to deploy to. And the next thing is about automated vulnerability scanners. Moti can talk about this.
Sure. So all of the previous methods allow you to test your smart contract according to specific tests that you have written. But it's also important to be able to check that your smart contract, whether your smart contract has any commonly found vulnerabilities. And so that's something that, for example, one tool that we offer, Inspect, which is currently in beta. And what Inspect does is it performs a static analysis of your smart contract. And then with that static analysis, it then checks your smart contract for common vulnerabilities, typically those that are on the weakness registry that Christoph mentioned earlier. And so the way it would work is you would upload your WASM bytecode and ABI. Inspect would perform the static analysis on the bytecode and ABI with the ABI, and then you would receive a report with any vulnerabilities that have been identified in your smart contract, which you can then fix and then rerun the static analysis to see if there are any other vulnerabilities that are still present in the smart contract. So if we move to the next slide. So all of these testing approaches might not catch all of the bugs and security issues, especially if there are bugs in your program logic, for example, or your application specific logic. And in that case, manual code audit by a specialized security firm is very useful. And they would typically check your code for issues, and they would also check whether the logic of your application logic in your smart contract is according to the specification of what it's supposed to do. There are quite a few firms that are out there that offer EOSIO specific smart contract audits. Just when you're selecting a firm, just make sure that they do have EOSIO specific knowledge and not just general blockchain smart contract audits. And then then I'll hand over to Christoph to continue with the next portion.
Yeah, another EOSIO specific thing is the permission and key setup. Like EOSIO has a very advanced way to deal with permissions. Like it has an MSIG way built into the whole platform that's usually not seen on any other smart contract platform. And so it's important to get accustomed to it and know how to use it. So the first thing is to make sure that your keys are actually fresh and not the same one as the testnet deploys that you did. So yeah, which is really needed. Like even maybe you passed around the testnet keys to some other developer, and yeah, it's just not a good practice. Always use fresh keys when you deploy to production, so you can be sure that this was not an issue, like using old keys. And also, if you're using a multi-signature setup for EOSIO, make sure that everyone from your team actually still has access to their keys. And a nice thing about EOSIO are that you can define custom permissions. And for example, let's say there's you developed some Oracle that feeds off-chain some prices to your smart contract. And of course, this transaction that feeds the price needs to run with some permission. And for this permission, you don't want to use the active permission that allows control over all actions, but you want to create a custom permission. As an example here at the bottom, which it says operator, and there's a Delphi Oracle.write link off. And what it does is it only allows this operator permission to run Delphi Oracle write actions. So let's say you run this Oracle in an off-chain script, and then you put your key for the operator permission there. And even if this key was leaked, all an attacker could do would just be to call the Delphi Oracle write action, but it wouldn't allow you to, it wouldn't allow the attacker to steal EOS tokens or do anything else with it. So that's always a very recommended way to split up your permissions into a hierarchy of from low security to high security. And another thing is to add any special permissions like EOSIO code, which you need when sending inline actions. Yeah, we also have developed a multi-signature permission PDF where we go into detail on different kind of multi-signature setups you can do, and like easy ones to set up, and then ones that are very secure but might be harder to set up and to manage. We will link to this PDF also at the end of this webinar. Yeah, and another EOSIO specific thing are the resources. Like the resource model, there are 3 resources that we have: CPU, net, and RAM resources. And it's important that your contract doesn't run out of it. So before deploying to production, make sure you have enough RAM and enough CPU and enough net. And this can be hard to estimate because it depends on quite a lot of different things. First of all, it depends on if you're paying for your user's transaction. EOSIO allows you to do that, or if the user pays for their own transactions. If you're paying for user transactions, then you, of course, need to schedule a lot more resources than if you just let the users pay for it. But having the users pay for it might lead to a pretty bad user experience, especially if your transactions consume a lot of computation costs. And one thing you can do is, so the way it works usually is you stake EOS or whatever the chain token is for your specific EOSIO chain. And if you stake it, you get this amount of CPU and net costs compared to all other stakes, compared to the total stake. But you can also, on EOSIO, some chains have the REX, which is the resource model, the resource exchange, and there you can actually rent CPU or net for 30 days. And this way you can get a big stake for a lot cheaper. For example, currently on EOS mainnet, 1 EOS is the equivalent of staking 2,500 EOS for 30 days. So it can be a lot cheaper, and it's usually a good way for devs that are just starting out to just rent CPU from Rex in the beginning. An alternative way, or one that also helps you here, is to use automated resource management systems like Shintai's ARM. And what they do is they consistently monitor your accounts, and whenever your free CPU or net resources drop below some threshold, they automatically rent more resources for you. And the same for RAM. You need RAM for 2 things. First of all, for storing the actual contract, and then for storing tables in RAM. So how to estimate how much RAM you need? Well, you can look at your contract size on the file system, and then you can multiply it by 10, which is the buffer that EOSIO uses. And then you need this amount of bytes for your account that you're going to deploy to. And for the storing tables, it again depends on if your contract is paying for the user's RAM, or if you're yourself paying for the RAM. And a quick way to estimate these things is also just to deploy your contract to a testnet and play around with it. Then you will see how much RAM you need, how much RAM different table entries cost, and also you get a feeling for the CPU and net costs, like how much CPU and net the different transactions need relative to each other. And another important thing is to keep track of smart contract versions. So EOSIO has this code hash that you can fetch from any account, and it tells you the specific hash of the code that's currently deployed. But this hash might first of all differ depending on your contract development toolkit version that you use. some compiler options or even the OS you're using. And this way it can be hard to relate the code that's currently deployed to the code you're running locally, especially if you keep developing and adding new features to your contract, you might lose track of which version was actually the version that's now running in production. So what I recommend doing is whenever you deploy something to production, you create a Git tag or a Git release, and then you tag it and write something, write the change log, and then you know, okay, this specific version is currently running on the mainnet. And then you can keep developing and not worry about getting confused. So, and also it's important to take your time, because you can go through as many checklists as you want. In the end, there's always things that can go wrong or unforeseen things that might happen. So it's good that you take your time, start early in your working day. So when things pop up that you didn't expect, you have enough time to go and fix them. And especially when you're doing a table migration, think about if you need to pause your contract or so that your users can't send actions while you're in the migration process, which might break some things. So yeah, make sure you're pausing this for any migration you're running, and then unfreeze it after the migration's running, or in between. Also check if the tables after the migration look good. And then run some transactions after you deployed a new production build, and then you can see, and hopefully everything works well. So here's some links to the resources we mentioned throughout this webinar. Like, first of all, you can get this checklist with some more explanations here on this link, the 11 things to do before releasing your smart contracts. Then there's also an in-depth review of all the different EOSIO testing environments you can use. And we also have a PDF for setting up multi-signatures that we mentioned that improve your smart contract security. And in case you have any questions or want to ask us anything, feel free to contact us on our Klevoya Telegram channel. We're there to answer any questions specific to deploying to production or about one of our tools that we're developing. So just drop by and say hello and ask us some questions.
Okay, thank you very much, Christoph, for that. So we now have some time for any question and answers. So if you want, you can either unmute yourself and ask us the question verbally, or if you prefer, there's also the chat button at the bottom of the screen where you can type in your question and we can answer that. So it seems that there are no questions. Hopefully that means that everybody found the content useful. So thank you, Christoph, for that. And yeah, so hopefully see some of you on the Telegram. Thank you all.
Yeah, thank you, and see you.